Good morning friends. In my last part 1 video, we discussed about the water side system installation details, and in continuation of the part 1 video, in part 2 video, today we are going to discuss about the HVAC system water side, all the accessories and some additional installation detail. So let's start the video. In the part 1 video, I explained about the hot tapping connection from the outside. So after the hot tapping connection, the supply and return line which is coming from outside to inside the ETS room, and when the pipeline is entering into the inside line, then here we have to provide one additional accessories called as a puddle flange in the wall. So let's see how the details of puddle flange comes. Like you see in this picture, so the outside line is coming from this side and which is entering into the ETS room or heat exchanger room. So here you can see the puddle flange which is installed in the wall. After that the concrete will be poured in this area. So the final look will look like this one. And normally this puddle flange we have different material. It comes with a different material like carbon steel, galvanized steel and stainless steel, etc. This material mostly it is based on what is the main pipeline material. So normally for the chilled water system or district cooling system, this material normally we use carbon steel ASTM A53. In the last video I explained about the grade and schedule also. So mostly this puddle flange material also will combine to the same material of carbon steel which is fixed in the wall. This is not only for the chilled water or district cooling system. If you go to other services also, whatever the service which is coming from outside and it is penetrating into the building, we must provide the puddle flange for all the service. But when it comes to inside the building, for example, here you can see the chilled water pipes or district cooling pipes are passing through different kind of walls. So when it comes inside the building, we don't need to provide the puddle flanges. Instead of puddle flanges, we can provide the normal pipe sleeve. So I'll show you one detail of that. Like you see in this image, I have shown the wall penetration. So this is our pipeline. So after the pipeline, here they have given the GI sleeve. So this is the GI sleeve. So this is the pipeline. So in between the gap has to be filled. So when it comes to mechanical or HVAC engineer and civil engineer, we have to consider one important point. That is, for example, this is the pipeline. This is the insulation with the cladding. Let's say that. So this is the insulation with the cladding side, and we have to provide the GI sleeve like this over that one. So this should be minimum 25 mm clearance should be there. For example, here 25 and here 25. All the side 25 mm clearance should be there. For example, this outer area, let's say it is 150 mm. That means the GA sleeve must be at least 200 mm. So here coming to the mechanical engineer or HVAC engineer scope of work, this gap between the sleeve, and the pipe, this has to be filled by the mechanical engineer or HVAC engineer. This is normally we can provide the fire sealant or any kind of material like shown here. They have mentioned like Oakum packing rope to seal the gap. And after that we have the wall here. For example, this is the wall. So this gap between the wall to the sleeve. So this gap normally considered by the civil engineer. So they will apply the concrete or some other material. But the sleeve to the pipe in this gap we have to consider in our tender stage, or we have to work out on the execution stage. Similarly, when it comes to the roof side, for example, you have a chiller in the roof like this. From the chiller line is coming and which is passing to the building through the vertical shaft like this. So here we have different floor levels. So from here we will take the branch. So when it comes to roof penetration, you must provide the arrangement like this. For example, this is the concrete slab. When it comes to the building pipeline like this. So again, as I told, you have to provide the proper mastic sealant like this, and proper solid black cork you have to provide. And here we have some waterproofing that is taken care by the civil. So similarly, if you see the duct also, when the duct is coming to the inside penetration, you have to provide proper sealant like this, and the top should be like a proper concrete slab should be provided, so the water will not pass into the shaft. Coming to the next point, so here you can see the pipeline, HVAC pipeline riser diagram. So for example, here you can see from the main riser, I have taken the branch for each floor level like this. So when it comes to this floor level tapping point, so at this point, we have to provide two very important walls, that is called as a isolation wall and balancing wall. So coming to the supply line, we will provide the isolation wall. Coming to the return line, we will provide the balancing wall. So this normally, we have two type of concept we need to understand from here. The first very important concept is the coming to isolation valve. We normally provide or we usually provide a butterfly valve or gate valve. When it comes to butterfly valve, mostly in the Middle East, I have seen like butterfly valve for the acting like isolation valve. So coming to the butterfly valve, two important things we have to consider. Till 6-inch line, till 6-inch butterfly valve, we are normally using the lever operated. Like you see here, we are using the lever operated, and more than 6-inch line, we normally use the gear operated, like this type of arrangement. And the second important thing, for example, here you can see the specification over 50 mm. They have mentioned this is ductile iron material, maybe in the wall body they are telling ductile iron, fully lugged body. This is one of the very important point we have to consider in the butterfly valve selection. That I will show you here what is the difference between lug and wafer type. So here in this image you can see this is the wafer type and this is the lug type. So they are particularly mentioning that we must not use the wafer type, we must use only the lug type, because lug type you can see there are plenty of flange holes are there like this. But coming to the wafer type, only there are two arrangements like this. So this is very strictly they are mentioning that we have to use only the lug type butterfly valve for the chilled water application. So normally this wafer type application, wafer type butterfly valve, we are not using the chilled water. This can be used in the other applications. And the second important point we have to see is the disc. For example, here the inside we have the disc. This disc normally comes with a different material. Brass will be there, only aluminum will be there. So here they have mentioned aluminum branch disc. So you have to consider in your project what is the material they are mentioning to particularly consider this one. Here in the project aluminum branch disc, this is a bit expensive. So you have to mainly consider this point. And finally they have mentioned suitable for installation between flanges. So here for example here the pipe lines are coming like this. So from the pipeline we are providing the valve, mean this should be suitable for installation of the pipe flanges also. So we have to consider these points also. When it comes to gate valve, we have to consider few important points. For example, here I have shown one gate valve. So the first very important point which normally I see here is the type of seating. For example, here we have two type arrangement. One is a resilient seated and another one is a metal seated. The prime difference between these two is, for example, here in the bottom of the arrangement you can see the wall is like this. So in the earliest and the recent one you can see the wall will come like a straight seating. That is called as a resilient seated. If you have the resilient seated like this, the disc will directly place like this. If you have the seating like this is called as a metal seating. So the disc will penetrate into this like this, and the arrangement has like this. So this is the chance that sometime the dirt or dust particles may settle in the bottom of this arrangement. So this is the metal seated. So nowadays the gate valve mostly we are recommending to keep the resilient seated. That means the bottom will be straight. So there is no chance that the dust or dirt particles or no particles will stay on this line. So because the lines are very straight. So this point is the first thing. Then coming to the second thing, we have to see the rising or non-rising stump, because when you open the valve like this stump will be go up and down. So if you are installing the gate valve for the underground application, you have to see the clearance, because for example if you have the valve chamber like this and this is the pipeline passing like this, so here you are installing one valve means, so you have to make sure that you have sufficient clearance between the slab bottom to the gate valve height. So when you open the valve, this valve will go high if you have the rising stump. If you don't have the rising stump, the stump will not go up. So we have to consider whether the valve is rising stump or non-rising stump, and we are using for underground or above ground application for the selection. And the third thing is till 50 mm, as usual, as I mentioned earlier also, till 50 mm it will come like a threaded type. Above 50 mm it will go to the flange side. So when it comes to flange side, the most of the side we do one mistake that I will explain here. In the chilled water system, the flange connection is one of the very important thing, because if you see in the ETS room, for example, there are strainers are there. So the strainer is the strainers are getting joined with the pipeline with the aid of the flanges. Similarly, if you go to ETS room, there are lots of valves will come, motorist valve, manual gate valve, and also we have the flow meters and BTU meter. There are different arrangements will come. So all these arrangement we have the flanges. So when it comes to the flange sizing, we will see what are the difficulty we will face when you order the material. So normally the chilled water system we are using three different material, like a welding neck type of flange, like you see here there will be some projection will be there. So the pipeline which is coming from outside will be joined with this line, so you can weld this line, and here you can see the bolt they have given. So for the flanges connection, like you see here this area, This is the flanges connection area, and here the pipeline one side we can join with the welding. And coming to the next important flange, that is the slip-on flange. So for this one, the pipe will penetrate into the flange like this, like you can see in the image also. The pipe will penetrate into this one, and here you can make the flanges like the fastener connection, nut and bolt connection. And coming to the third one, this is a threaded flange. This is for the normally used for the lower size. So we have the threaded connection like this, and here also you can make the connection. So these are the three important flanges we are using, and also you can see the blind flange also. Blind flange normally we are using the ETS room, so for the end connection. So this flanges connection, I mean these holes, it must match with the tapping connection. For example, you are installing this same flanges with the walls. So for example, when it comes to the wall or the flow meter, like you see here, you have to provide the flanges to connect with this line also. So that time both the nut and bolt or the fastener has to match with the flow meter as well as the piping flanges. So coming to the flanges, we have two important standard we are referring. So the first one is the ASME B16.5. This is for the flanges till 24 inches. So above 26 inch to 60 inch, we can use to this reference standard ASME B16.47. This is mostly asked in the interview for the piping side. And here we have to make sure the flanges of the flow meter as well as the piping flanges are matching, because sometimes we are getting the flow meter from the Europe countries, so they will follow the British standard, and we are getting the flanges from the American countries, so they will follow the American standard like this. So both will not match, so we have to make sure these both have the proper connection when it comes to the order. So like you see here, the expansor tank, like the flange connection will be there. So expansor tank, air separator, and all the accessories in the ETS room and chilled water system mostly have the flange connection. We have to make sure this point is properly considered. Coming to the third important point, so here you can see from the main riser, this line is distributed to different apartments. So when it comes to apartment, we must consider one very important item, that is called as a BTU meter. So BTU meter for the flow measurement we are using for all the individual flat connection. For example, this is the chilled water supply connection which is coming from the main riser. For example, this is the main riser. For this we have an apartment here. For this individual apartment flow measurement, we are using the BTU meter here. So here this supply connection, in this application we have the item called T. So if you see this abbreviation or legend here, T, they have mentioned temperature sensor and transmitter. So this is the first item in the supply line. After that we have the gate wall also for the isolation purpose. When it comes to the return side, again we have the another gate wall. So again we have another T, that is a temperature sensor and a transmitter. And after that we have the inline ultrasonic type. So like you see here, so we have the BTU meter calculator here. So we have the connection from here, and after that we have the drain point. So DP means a drain point, so to drain the water. Then we have the isolation wall again. So in this line we can see there are two isolation wall, front and back side of this arrangement, because if you want to do any maintenance at this level, we can close these two isolation wall for the maintenance. And the third isolation wall we have in this supply line. After that we have two drain point in the supply and return line. Then we have the temperature sensor and transmitter in the line. So these are the important accessories we have to consider for the BTU meter. Normally in the water side HVAC system, similar to this arrangement, we have lots of accessories will come, like automatic air vent and drain connection. For example, if you go to the riser side, so the top of each riser, for example this is the riser connection for our case. So the top of each connection, that means at the roof level, normally we can see the automatic air vent which is installed at this point. So the automatic air vent has to be provided in the top of the riser, and below also we will provide the drain connection. So this automatic air vent we must have with one isolation wall. For example, below the automatic air vent we will have one isolation wall. So if you want to do any maintenance, we can close the isolation wall and we can remove the maintenance in the automatic air vent. So after automatic air vent we can see the drain wall also. So many times in the AHU or the other accessories, this drain wall will come. This is mostly we are using the ball wall as a drain wall. And similarly we have the test plug connection. So this test plug will come in the AHU supply return side, and similarly for the FCU side. So ETS room there are different test plug will come to measure the temperature value manually and to like a calibration type arrangement. And the next one we have the pressure gauge, temperature gauge. So these are the different accessories we normally use for the HVAC water side. And when it comes to installation, we must know very important point. For example, if you go to the same the discussion of the BTU meter like we discussed earlier, so here you can find one drain point like this. So this is the main line. From the main line, how you will provide that connection for the drain point, because the drain point size is very low, the main line size is very high. So how we can make the branch connection like this? When it comes to branch connection, here I will explain two important branch connection type of. For example, this is the main line, like going like this. So this is the 100 mm. This is the first case. The main pipe is 100 mm. I want to take one branch with 75 mm. So in this case, I can reduce the reducing T. So to take the branch up, so the main line will be 100 mm. So this reducing T will be 75 mm. When it comes to the second case, and the important thing, the main pipe is 100 mm. The branch for the drain wall I have to take for 20 mm. So this is 100 mm, and the branch I have to take for 20 mm. So in this case, if you produce a reducing T, how you can make the 100 mm to will make one reducing T. Again we have to provide one reducer. Again, so this there are two more fittings will come. And secondly, if you we have a very general thing, like if you want to take the branch, for example, this is the main line with 100 mm, and when you are taking the branch, if the branch size is less than half, that time you can go with the other arrangement called as a weldolette or threadolette. Less than half means, for example, the main line is 100 mm, the half of the 100 mm is 50 mm. So the branch connection is less than 50 mm. That means here in our case it is 20 mm. So if it is less than half means we can go with the alternate arrangement instead of the reducing T, that is called as a weldolette or threadolette. So till 50 mm we will go with the threadolette, above 50 mm we will go with the weldolette. So this weldolette connection will directly sit on the pipeline of the main pipes. We can do the welding in the weldolette, like you can see the welding, you can do the welding in the bottom here. So here the pipelines, the main pipeline will be there, and this branch, this weldolette will be directly sitting on the main pipeline. So here you can do the welding. So this is for above 50 mm and threadolette is for less than 50 mm. So if you have the condition like this, you can use the branch connection like this. So this is the arrangement normally we are following for the test plug, drain pipe, drain wall, whatever the small branch which is coming from the main pipeline. Coming to the next important point, that is the chilled water system insulation. So overall for the chilled water system we have to provide the insulation. So here you can see there are two very important insulation normally we use in the Middle East. The first one in the left image, you can see the flexible closed cell elastomeric rubber insulation, like you see in the black color one. So this is the flexible closed cell insulation. Coming to the right side, we have the another important thing, that is the cross linked closed cell polyolefin thermal insulation foam. So these are the two important insulation we normally use in the Middle East. After the insulation we have the aluminium coil or aluminium cladding. So based on the location, the thickness of the insulation will vary. For example, the same insulation, if you are using the roof, that means the exposed to sun, the insulation thickness will be high. If you are using the inside condition area, the thickness will be low. So you have to make sure what is the thickness of the material. Coming to the next important thing in the piping side is the support. For example, here I have shown two type of support. The first one, for the pipe size less than 50 mm, we are using the band hanger, and coming to the higher size 65 mm and above, we are using the most familiar one, clevis type hanger. So here you can see the image. The first image table for the chilled water piping, and the second one is the copper piping. So for the carbon steel and all these things, we normally use this first one. So here you have given this different type of pipe sizes up to 25 mm, 32 to 50 mm until 350 mm and above. For all the sizes we have given the value. So the distance between the support, so this arrangement we are using for the horizontal piping, not for the vertical piping. Vertical piping we have separate one that I will show you now. So for the horizontal piping up to 25 mm, maximum distance between the two support is 2 meter, and 32 to 50 mm it is 3 meter. So like this different values are given. So coming to the rod size, like you see here the rod, so the sizes of the rod for the different sizes is mentioned again here. Sometimes we are proposing this type of arrangement also. For example, this is the supply and return pipeline we have given. So after the pipeline we have the rubber insulation here. So from here we have the slab. So from the slab first we have the threaded rod. So this threaded rod we are connecting with the C channel, like you see here. This is the C channel. So we have the support nut and washer we have, and lock nut we have. So this one we can connect with the C channel like here. And after that, after this one, before providing the this type of arrangement, so we will provide this rubber inset, like you see here, we will provide the rubber insert here. So after that the support will be directly connected with this one. We have to make sure that we are not damaging the insulation when we provide the support like this. Inside the slab we have the expansion board. So in the section view it will look like this after the installation of the supports. Similarly, when it comes to the vertical pipeline, for example, here you can see this arrangement. So this is the RC wall, this is the vertical pipeline which is passing in the shaft and other area. So the first arrangement we have the expansion bolt which is connecting with the wall. After the expansion bolt, we have the steel channel, like you see here is the steel channel. Then after that we have the U bolt or band strap, and the rubber insert, as I explained here, it will be installed in between the pipeline here. So this U bolt, band strap and expansion bolt and this channel, we have to follow some arrangement like is shown here in this table. So here for the different pipe size they have given the arrangement, the steel channel size they have given, bolt and the strap size they have given, the expansion bolt size they have given, and mainly the maximum hanger interval for different pipe size they have given. You can see when the pipe size is getting higher, the supporting interval also will getting higher. And one important announcement, currently in our channel we have 5710 subscriber. So as soon as we reach the 10,000 subscriber, I will post a very detailed design video which consists of around 3 hours video from starting to end of the high-rise building. So how to start the project, from what are the points we have to consider, and how to design from each and everything, including the pipes, duct, everything of the HVAC design. So I request you to please subscribe the channel. Please encourage us to post more and more video. Hope you will receive the 10,000 subscriber as soon as possible. Coming to the last points of today's video, that is the branch takeoff. For example, this is the main line. From here I have to take the branch for this FCU and this FCU. So how will take the branch from this main line? Because for example, if you zoom this line, we have two connections, supply and return. So main line, one line I can take like this. For this connection I can take straight away like this. When it comes to this connection, I have to cross this line and I have to go, because if you go to the section side of this one, you can see that one clearly. For example, this is the underground pipeline. So here also you can see there are two lines which is passing like this, and I have to take the branch takeoff connection. So what I have done for the underground line, for this is the supply, I have taken straight away. When it comes to the return line, I cannot take straight away because I have to pass the supply line. So I have taken above like this. Then after crossing the one line, I have taken the straight away like this. So this is the way we can take the branch up. When it comes to underground line, I have taken it above like this, and it is a very good engineering practice. You must take the line always above. If you take the line below and making down, so there is a chance that the dust and duct particles will be settled down in the bottom, in the some side. So it is always recommended to take from top and take like this. So this is for the underground line. When it comes to building side also, you always try to take the tape off from the top side, not from the bottom side of the connection. So I believe in this part 1 part 2 video you learned some installation idea about the chilled water system. So coming to the part 3 video, we are going to start with the air side. So air side we have different important points. We are going to discuss about the supply duct, return duct of AHU, FAHU and this type of unit, and we are going to see the exhaust ventilation, toilet, kitchen duct and smoke pressurization duct. What are the important points we have to consider when it comes to the sensor, defensive pressure sensor, when it comes to the air outlet and discrete diffuser, VAV, and all these things we will see in the coming from the next video. So thank you for watching the video. Please don't forget to subscribe the channel. Thank you. Bye bye.